Hello everyone. Today we are going to extend our dynamic model to include the firm, and based on that we are going to integrate the static and the dynamic components to have an all-in-one RBC model. This chapter marks the end of RBC model, which focuses on the real factors underlying the short-run business cycles. This is the basis for all modern business cycle models. In first lecture on dynamic models, we have developed a simplified two-period dynamic model with consumers only. In the second lecture, we extend it to include the government, so the demand side of the output market has consumption C and government G. In the complete version of the real business cycle or RBC model, we should also have the supply side of the output market, the firm, which employs both labor and capital to produce output. Also, we can extend the two-period framework to infinite time horizon. This is what we are going to do in this lecture. We will combine all building blocks we have developed separately in previous lectures to arrive at an all-in-one RBC model. It includes consumers who maximize utility subject to constraints, firms who maximize profit subject to technology, government which makes its ends meet, and all markets must clear. Note that once firms are introduced, there is one more market, the capital market. This big picture shows you where we are. We started with the static model to explain business cycles in the labor market, where we derived the intra-temporal conditions. By allowing for search and matching frictions, we can further explain the extensive margin in the labor market. Then, we developed dynamic models where we derived the intertemporal conditions. By allowing for asymmetric information, we can further explain the effect of fiscal policies. Now, we are going to combine the two building blocks in the all-in-one RBC model where all the conditions we have derived still hold. The final piece missing for this all-in-one model is investment in the capital market. Let's see how it fits in the model. Investment is a flow variable which forms the stock of capital over time. It is the decision made by firms to maximize its profit in a dynamic setting. It includes expenditure on plants, equipment, and housing. Investment takes a while to form the capital stock, so the decision is intertemporal by nature. As we mentioned in the first lecture of dynamic models, capital market is similar to credit market in the sense that they both represent a trade-off between current and future periods. The credit market takes the view from the consumers, while the capital market is from the firm's point of view. The connection between the two markets is the real interest rate, R, which is the price of the trade-off between current and future periods. The interest rates of the two markets must equal. Otherwise, there is arbitrage opportunity between financial investment by consumers in the credit market and fiscal investment by firms in the capital market. Therefore, we can finally complete the conceptual framework of our model. The blue circle here represents savings by consumers in the credit market, and the red cycle represents investment by firms in the capital market. If we combine the two dynamic decisions with the static decisions in the labor market, we will have a complete RBC model. Today's learning objective is to know how to set up this all-in-one RBC model. To make sense of the complicated equation system, we are going to integrate various conditions into an aggregate supply or AS curve and an aggregate demand or AD curve. To make your life easier, we are only going to do so in graphs, but you should make sure you understand the mathematical logic behind the graphs. Finally, we will summarize how we can use this all-in-one RBC model and its extensions to explain business cycle facts. First, let's do the Lego game and build the all-in-one RBC model. It is a micro-founded model like before, so it has optimization conditions for all three agents: the consumer, the firm, and the government. It also has equilibrium conditions or clearing conditions for all markets. Let's look at the mathematical way of modeling the representative consumer's optimization behavior. The objective function is dynamic, so the current utility and the future utility are linked by the subjective discount factor, beta. Within each period, the consumer cares about both consumption C and leisure L. If we substitute out leisure L and L prime by time endowment H minus labor supply in the two periods, we have the following. The budget constraints of the two periods should therefore include labor income W multiplied by N, which was assumed away in the simplified dynamic model. Note that for the representative consumer, lending and borrowing among individual consumers cancelled out. So the budget constraints here only describe the net borrowing between the government and consumers as a whole. Therefore, the private savings of the consumer, SP, is usually positive because the government is usually the net borrower from the public. To simplify, we can substitute out the common term SP in the two constraints, resulting in a lifetime budget constraint, just like what we did in the previous two lectures. The left-hand side describes the present value of consumptions, while the right-hand side describes the present value of income, including labor income Wn and capital income pi, net of taxes T. The right-hand side is also termed as wealth WE. To solve the optimization problem, we usually use an alternative approach of substitution. Instead of substituting out SP, we can substitute out C and C prime in the objective function by the two budget constraints. This is more convenient because we have two less variables to worry about. You can of course substitute out SP like what we did in the previous lecture, but the process would be a little bit more tedious. You're encouraged to try both ways of substitution and check if they give you the same results. If we substitute C and C prime out, then we have only three control variables left in the optimization problem. They are labor supply in the current period, N, labor supply in the next period, N prime, and private savings, SP. If you take derivative of the new objective function after substitution with respect to the three control variables and equate the derivatives to 0, we will have the optimization conditions for the representative consumer. Not surprisingly, we have two sets of optimality conditions. The first set is intratemporal conditions, which describe the optimal trade-off between consumption and leisure in the two periods. The second set is the intertemporal condition, which describes the optimal trade-off between consumption in the current period and the consumption in the future period. These optimality conditions are for individual consumers who are price takers. Therefore, if we solve for the three endogenous variables, labor supply in the current period N, labor supply in the next period N prime, and savings SP, then we can treat prices like wage and interest rate as exogenous. In other words, at the individual level, the solutions to the three endogenous variables can be expressed by prices. We have three conditions and three unknowns, so in principle we can solve for all. It is a very tedious job to solve this equation system, so you are not required to do so in this module. In fact, you will do that in your Year 3 macro. Nevertheless, you should know that it is nothing but substituting out n-1 unknowns from n equations. We have 3 equations and 3 unknowns here. It is not difficult, just tedious. And as long as you are patient enough, you should be able to solve it at the end of the day. Instead of showing you the boring maths, we will use graphs instead to show the intuition of maths. Remember that graphs are just the equivalent way of showing the maths. It is not precise, but very intuitive. You don't have to memorize the graphs. You can always derive the graphs from the maths. So don't abuse your imagination when using graphs. Each curve and each shift of curves have maths behind. Let's derive the graphs of the 3 conditions we have just seen earlier. For your convenience, I reproduce the 3 conditions at the top of the slide. First, what is the graphical counterpart of the intratemporal condition in the current period? The condition is W equals to MRS between leisure and consumption. In this equation, wage W is exogenous to individual consumers because everyone is price taker. Leisure and consumption are endogenously determined by consumers in the model. Causality always runs from exogenous to endogenous, so we start the analysis from a change in the exogenous variable, wage. Let's use an exogenous rise in wage to start the analysis. In this case, the left-hand side of the condition rises, which violates the optimality if nothing has changed on the right-hand side. To restore the optimality, consumers must raise the right-hand side of the condition to rebalance. So the MRS on the right-hand side must rise. To make that happen, leisure must drop according to the diminishing law. Recall that diminishing law means a higher leisure leads to a lower MRS. Reversely, a lower leisure leads to higher MRS. A drop in leisure means a rise in labor supply. So to summarize, a rise in wage results in a rise in labor supply. This corresponds to an upward sloping labor supply curve. Now you know that the upward sloping labor supply curve is not just a story, but well based in mathematics. Similarly, in the future period, the intratemporal condition here implies an upward sloping labor supply curve in the future period. Now let's move to the intertemporal condition. Like the intratemporal condition, we should start with the change in the exogenous variable. In this condition, interest rate is exogenous. Consumption is endogenous. If there is a rise in interest rate, the left-hand side of the optimality condition rises. To restore the optimality, the right-hand side, the MRS, should also rise too. Again, according to the diminishing law, consumption must drop to achieve that. To summarize, a rise in interest rate is associated with a drop in consumption, which corresponds to a downward sloping consumption demand curve. If we look at the budget constraint, a lower consumption implies a higher saving, just like a lower leisure implies a higher labor. To summarize, a higher interest rate is associated with a higher saving, which corresponds to an upward sloping credit supply. Let's now see the graphs. We have seen that the shape of the labor supply curve is positively sloped, which can be derived from the intratemporal condition. We also derived the shapes of the consumption demand curve and credit supply curve, which are not shown here. I would like to give another important example of graphical analysis. We know that interest rate is exogenous, and it can affect consumption according to the intertemporal condition. but consumption C appears in both inter- and intratemporal conditions. Therefore, a change in R will have spillover effect in the intratemporal condition via consumption. To see that effect, we still base the analysis on the three optimality conditions. If there is a rise in R, the left-hand side of the intertemporal condition rises. To restore the balance, MRS must rise and consumption C must drop according to the diminishing law. When C drops, the right-hand side of the intratemporal condition must change. Note that W is exogenous to individuals, so we cannot change wage. To restore the balance, the only way is to proportionately adjust leisure, because MRS is defined as the ratio of marginal utilities of leisure over the marginal utilities of consumption. To summarize, for any given wage, a higher interest rate R results in a lower leisure or a higher labor supply. In graph, it means a right shift of the labor supply curve, as shown in the middle. The effect of interest rate on labor supply curve is also called intertemporal substitution effect, which we will keep using in this lecture and in the future. So please do try to understand how we arrive at this conclusion graphically based on the three mathematical equations. In fact, this is an example of a generalizable process of graphical analysis. We will frequently use this generalizable process in the future. So let me summarize it here. I will repeat this several times in the future, so don't worry if you can't memorize it right away. Step 1. You should first distinguish exogenous variables from endogenous variables. For individuals, prices like wage and interest rate are exogenous, while decision variables like labor and consumption are endogenous. The tricky part is that if we are talking about the market, prices become endogenous. So it is essential to know the context. Step 2. You should then distinguish shape of curves from the shifts of curves. In economics, graphs are usually two-dimensional, so there are only two axes. If we want to know the relationship between the two axis variables, then the analysis is about the shape of the curve or the shifts along the curve. In contrast, if we want to know the relationship between one axis variable and a non-axis variable, then the analysis is about the shifts of the curve. For example, the relationship between wage and labor supply is the shape of the curve because both variables are axis variables in the labor market, while the relationship between interest rate and labor supply we just discussed is the shift of the curve because interest rate is not the axis variable in the labor market. Step 3. Analysis. After knowing which are exogenous and which are endogenous, the analysis should always start with a particular change in one exogenous variable. Note that we usually start with a rise of the exogenous variable, but you can of course start with a drop of the exogenous variable. The only difference is that the directions of analysis will all be reversed, but the resulting relationship should be the same. Another important point is that if you have more than one exogenous variables in the system, then you must keep all the other exogenous variables fixed when you focus on only one exogenous variable. You cannot change two exogenous variables at the same time. Exogenous means that the variable is determined outside the model. After assuming a particular change in one exogenous variable, you can then analyze the effect on the endogenous variables based on all the equations in the system. Most likely, you will need to utilize the diminishing law as we have just demonstrated. The diminishing law includes the diminishing marginal rate of substitution and diminishing marginal product of labor or capital. Note that there may be spillover effect from one equation to another, like the intertemporal substitution effect when we analyze the effect of interest rate on labor supply. The right graph here shows you the effect of income Y on labor supply curve. Let's use the three-step approach to do it. Step 1. We treat output Y as exogenous, like wage and interest rate, while labor supply and consumption are endogenous. Step 2. Output is not an axis variable of the labor market. So we are talking about the shifts of the curve, rather than the shift along the curve, or the shape of the curve. Step 3. Start with a rise in the exogenous variable output Y. We know that consumption will rise because of the permanent income WE rises. This will change the right-hand side of the intratemporal condition. To restore the optimality condition, you cannot change wage W on the left-hand side because it is exogenous to individuals. The only way is to raise leisure proportionately. A higher leisure means a lower labor supply. To summarize, a high income Y results in a lower labor supply for any given level of wage. So it is a left shift of the labor supply curve. These examples show you how we should do the graphical analysis. It is strictly logical and based on the mathematics. All your analysis must be derived from the mathematical equations, despite demonstrated in graphs. If you follow the three-step approach, you will not get confused where to start and what to shift. Now let's move from consumers to firms of this all-in-one RBC model. Like consumers, firms are also rational decision makers. In a dynamic setting, the representative firm maximizes the sum of present values of profits. Recall that in the static setting, the objective function is just profit of each period. But now we need to deal with profits in both periods, since your investment decision today affects both current and future periods. The discount rate is the market interest rate R because it is the opportunity cost of capital. You could have earned an interest of R in the bank if you do not invest in physical capital to produce in the firm. The profit in the current period is equal to the output Y minus the labor cost W multiplied by N and investment I. The profit in the future period is equal to the output Y prime plus the net capital minus labor cost W prime multiplied by N prime. The net capital here is equal to 1 minus the depreciation rate of capital D multiplied by the capital stock in the future period K prime. The firm faces three constraints. The first two are production function of the two periods, and the third one is the law of motion of capital. The production function is again implicit here to keep generality, but in practice we usually assume a Cobb-Douglas specification for the production function, FKN. The implicit production function simply assumes that output is produced by two inputs, capital K and labor N, disturbed by the total factor productivity Z. For the law of motion of capital, the left-hand side is the flow of investment I. The right-hand side is the change of capital stock. Think of capital stock as the level of water in a tank. Investment is the water flow into the tank, so depreciation is the evaporation out of the tank. The change in the level of water depends on the net flow into the tank. Two notes are due here. For simplicity in our two-period model, we assume the residual value of capital 1 minus d multiplied by k prime, can be turned back to output at the end of the future period. That is why 1 minus d multiplied by k prime is part of the revenue in the future period. In a model with infinite periods, the residual value of capital does not turn into revenue because it will be carried over to the next period for production forever. Also notice that the capital stock in the current period, K, is a given state variable, which is not under your control. We can only change the capital stock K prime in the future, not the capital stock today. Again, like in the consumer's optimization problem, we can substitute out three endogenous variables y, y prime, and k prime using the three constraints. It ends up with a long, scary objective function without constraint. The red is actually the profit in the current period, and the blue is the profit in the future period. After substitution, we have three endogenous control variables left: labor demand in the current period, N, labor demand in the future period, N prime, and investment, I. What makes the optimization problem dynamic is investment, I, because it affects both today's profit negatively and tomorrow's profit positively. Like all optimization problems, we take partial derivatives of the objective function with respect to the three endogenous control variables. Skipping the algebra, we have derived two sets of optimality conditions for the firm. The first two are the intra-temporal conditions describing the labor demand in both periods. The second is the intertemporal condition describing the capital demand. The intratemporal conditions are exactly the same as what we have derived in the static version of the RBC model. The intertemporal condition is new, but similar to the intertemporal condition of the consumer in the credit market. The essence is the same. The left-hand side is the opportunity cost of capital, and the right-hand side is the marginal product of capital. Again, for the price-taking firm, wage and interest rate are both exogenous, so we have three equations for the three unknowns. In principle, we can solve for all. The previous slide is the mathematical procedure to solve the firm's problem. We can of course show it in a graphical way. Let's apply the three-step approach to derive the shapes of the three conditions. The first condition is the intratemporal condition. W equals to the marginal product of labor. Step 1. We know that labor demand N is the endogenous variable, while wage W is exogenous. Step 2. We are trying to figure out the shapes of the labor demand curve here. Step 3. Start with a rise in the exogenous variable W. The left-hand side rises. To restore the optimality condition, the right-hand side, marginal product of labor, should rise as well. According to the diminishing law, labor demand must drop to have a higher marginal product of labor. To summarize, a rise in wage is associated with a drop in labor demand. Therefore, the shape of the labor demand curve is downward sloping. The same analysis applies to the future labor demand curve. The intertemporal condition R plus D equals to the marginal product of capital in the future period. Step 1. We know that capital demand K prime is endogenous, while interest rate R is exogenous to the individual firm. Step 2. We are trying to figure out the shape of the capital demand curve here. Step 3. Start with a rise in the exogenous variable R. The left-hand side rises. To restore the optimality condition, the right-hand side, marginal product of capital, should rise. According to the diminishing law, capital demand must drop to have a higher marginal product of capital. To summarize, a rise in interest rate is associated with a drop in capital stock in the future period, K prime, or equivalently, a drop in investment in the current period, I. Therefore, the shape of the capital demand curve is downward sloping. The textbook also extends the intertemporal condition to address the possible consequences of asymmetric information. The financing cost includes not only interest rate, R, but also an extra default risk premium, X. The extended intertemporal condition becomes this. In the previous slide, we have shown that the labor demand curve and capital demand curve are both downward sloping. This slide focuses on the effect of exogenous variables on these curves. For example, to see the effect of a rise in productivity Z, we again apply the three-step approach. Step 1. The exogenous variable in question is Z, and the endogenous variable is labor demand. Step 2. We are talking about the shift of the curve, because these variables are not axis variable. Step 3. Start with the rise in Z, keeping all the other exogenous variables such as wage and capital stock unchanged. It results in the higher marginal productive labor on the right-hand side of the intratemporal condition. To restore the optimality condition, you cannot change wage on the left-hand side because it is exogenous to individuals. The only way is to decrease marginal productive labor on the right-hand side to cancel out the rise. According to the diminishing law, we must raise labor demand to decrease marginal productive labor. To summarize, a rise in Z is associated with a rise in labor demand for all given wages. That means the labor demand curve will shift to the right. The effect of a rise in capital stock K is similar to that of a rise in Z because both results in a rise in marginal productive labor on the right-hand side. Now let's analyze the effect of productivity Z prime in the future period on the capital market. Note that productivity in the current period Z does not have any effect on the capital market because capital in the current period is already fixed. Again, apply the three-step approach. Step 1. A rise in Z prime raises the right-hand side of the intertemporal condition because Z prime is part of the marginal productive capital in the future period. To restore the optimality condition, you cannot change anything on the left-hand side because R and D are both exogenous to firms. To cancel out this rise on the right-hand side, you can only decrease marginal productive capital by raising the capital demand according to the diminishing law. To summarize, a rise in Z prime is associated with a rise in capital demand for any given level of interest rate. So it is a rightward shift of the capital demand curve. I will leave the analysis of other exogenous variables such as the default risk premium X to you as an exercise. Remember to follow the three-step approach. Do not count on your imagination or intuition. Use your logic. Now that we have analyzed the optimal decisions of the consumer and the firm, both mathematically and graphically, we are now ready to combine them for the competitive equilibrium in the all-in-one RBC model. To summarize, we have the following four sets of conditions. First, all consumers optimize. This implies that both intratemporal conditions and intertemporal conditions of the representative consumer we have derived earlier must hold. Second, all firms optimize. This implies that both intratemporal conditions and intertemporal conditions of the representative firm we have derived earlier must hold. Third, the government's lifetime budget constraint must hold. Fourth, all markets clear, which implies that supply equals to demand in all the following markets. According to the Walras law we have mentioned many times before, one of the market clearing conditions is redundant. Mathematically, once we simplify and collect all the equilibrium conditions, we will have 11 equations for the 11 unknowns in our case. There are 3 conditions from the consumer's optimization problem, 3 from the firm's optimization problem, 1 from the government, and 4 independent market clearing conditions. It is quite a challenge for an undergraduate student to solve such a complicated system of equation, so it is not required in this module to explicitly solve for the equilibrium. But as I mentioned many times before, you should be quite confident that as long as you are patient enough, you should be able to solve it, because the principle of solving all simultaneous equation system is the same. That is the method of substitution. You simply substitute out n-1 unknowns from the system until you have only one unknown, and then you solve for it. As long as you know the principle behind the method of substitution, it is enough for now. Here are some technical notes for those who want to challenge yourself in mathematically solving the model. There are 11 endogenous variables or unknowns. If we impose market clearing conditions or supply equals to demand, then NS, the labor supply, is equal to ND, the labor demand. So we can replace both by a single variable N. Similarly, N'(S) and N'(D) can be replaced by N' in the future period. If we do so, it is equivalent to having used the 2 clearing conditions in the labor market. The 4 unknown variables now become 2 unknowns, N and N'. This is to tell you that if you use one equation, you must substitute out one unknown. If you use 2 conditions, you must substitute out 2 unknowns. This is the algebraic logic underlying equation solving. Another mathematical note is that if you want to solve for any other unknown variables, which have already been substituted out in previous steps, such as consumption and leisure, then you have to reintroduce them back into the system based on the used conditions, such as budget constraints and time constraints. This is to tell you the same algebraic logic underlying equation solving. The number of equations should always be equal to the number of unknown variables in the equation system. Since a quantitative solution is too difficult to obtain, we will use graphs to show the qualitative solution of the competitive equilibrium. However, please note that although we are using graphs, all the analyses are based on the 11 equations. They are not 2 things. They are the same thing. Therefore, the graphical analysis of general equilibrium is still mathematically based. In mathematics, it does not matter which equation should be combined and which unknowns are to be substituted out first. But in economics, it makes sense to first combine intra-temporal conditions of the consumer and the firm, because they describe the supply side of the output market. Again, we follow the 3-step approach. Step 1. The exogenous variable we focus on is interest rate, which is the price of the output market. The endogenous variable we focus on is output, which is the quantity of the output market. Step 2. We are talking about the shape of the aggregate supply curve in the output market, because it is the relationship of the 2 axis variables, price and quantity, in the output market. Step 3. Start with a rise in the exogenous variable, interest rate R, from R1 to R2, for example. We have seen on slide 11 that a rise in interest rate will lead to a right shift of the labor supply curve due to the so-called intertemporal substitution effect. If you forgot, please go back to the slide 11 to revise. The equilibrium employment in the labor market will rise from N1 to N2, and the wage drops from W1 to W2. Recall that when we analyze the individuals, consumers and firms are all price takers, so wage is treated as given. Since we have already combined the supply side and demand side of the labor market, wage is now endogenous. The rise in labor input will lead to a rise in output via the production function. To summarize, a rise in R is associated with a rise in Y, which means that we will have an upward sloping aggregate supply curve in the output market. The rest of the 11 equations are intertemporal conditions and market clearing conditions, which can be used to describe the demand side of the output market. Again, let's apply the three-step approach. Step 1. We focus on the output market, so the exogenous variable in question is interest rate, and the endogenous variable is output. Step 2. We are talking about the shape of the aggregate demand curve in the output market because it is the relationship of the two axis variables, price and quantity, in the output market. Step 3. Start with the rise in interest rate from R1 to R2. Based on the intertemporal conditions of the consumer and the firm, a rise in R results in a drop in consumption C and a drop in investment I. You can apply the three-step approach to see why C and I drop here. The aggregate demand is equal to C plus I plus G, so the aggregate demand shifts down as R rises. Combined with the market clearing condition supply equals to demand, we can derive that the output decreases from Y1 to Y2. To summarize, a higher interest rate is associated with a lower output demand, which implies a downward sloping AD curve. Now we used up all the 11 mathematical conditions in our graphical analysis. After combining the intratemporal, intertemporal, and market clearing conditions, we end up with only two curves: an upward sloping aggregate supply curve and a downward sloping aggregate demand curve. Once we combine the two curves in the output market, interest rate becomes endogenously determined. Recall that prices are all exogenous to individuals but endogenous to the market. The equilibrium output level Y star is determined at the same time as the equilibrium interest rate R star is determined. If there is a change in an exogenous variable such as productivity Z and government expenditure G, we can then apply the three-step approach to graphically analyze the effect on the curves and the new equilibrium. To deepen your understanding of the relationship between maths and graphs, I will once again repeat how the equilibrium is solved in both ways. We know that the competitive equilibrium is simply the solution of the simultaneous equation of the 11 unknown endogenous variables. Based on algebraic principle, you can use any order of substitution to reduce the 11 equations down to only one equation with only one unknown and then solve for it. But economic logic can help to understand the intuition behind the graphs and simplify the process of solution. According to the nature of the conditions, we can group them by intratemporal and intertemporal conditions. Noting that output is the central variable of any macroeconomic models, so we combine conditions to form the supply and demand sides in the output market. Input markets like labor and capital are therefore on the upstream of the analysis to feed into the output market. But again, as we emphasized earlier, all markets clear at the same time rather than sequentially. To summarize what we have done, the intratemporal conditions form the supply curve and demand curve in the labor market, which leads to the aggregate supply curve in the output market. The intertemporal conditions form the demand for consumption and investment, which translates to the aggregate demand curve in the output market. Combining the AS and AD curves results in the equilibrium interest rate, output, as well as other endogenous variables. This slide explains the idea in the previous slide further. The intratemporal conditions are exactly the same as those derived in the static RBC models, while the intertemporal conditions are the same as those derived in the dynamic RBC model. The AS and AD curves are derived by combining these conditions and substituting out some endogenous variables. This boils down to only two equations, the AS curve and the AD curve, with two unknown endogenous variables, interest rate R and output Y. Luckily, you are not required to actually solve the equation system mathematically, but just graphically based on the mathematical equations. Building on the mathematical and graphical understanding of the all-in-one RBC model, we are now ready to apply it to explain business cycles. Don't forget, our question is short-run fluctuations of the economy, which are measured by the stylized facts introduced in lecture 0.3. The all-in-one RBC model is just the method we adopt to answer the question. There are basically two traditions in macroeconomic theory to explain business cycles, as we mentioned many times in the past. Now we are going to summarize the two schools of thought again, based on the all-in-one RBC model. The classical or neoclassical economists argue that it is the supply side that drives the business cycles. Specifically, the fluctuations in productivity Z are regarded as the fundamental driver. To see how this theory works, let's see how Z affects output Y. Let's follow the three-step approach again. Step 1. The exogenous variable in question is Z, and the endogenous variable at focus is output Y. Step 2. We are talking about the non-axis variable Z, so it is about the shifts of curves, not shapes of curves. Step 3. Start with the rise in the exogenous variable Z while keeping all the other exogenous variables such as government expenditure unchanged. We have seen in the labor market that a rise in Z shifts the labor demand curve to the right, resulting in a rise in equilibrium labor and a right shift of AS curve in the output market. So the equilibrium output rises from Y1 to Y2, and the equilibrium interest rate drops from R1 to R2. Is this the end of the analysis? Not really. The effect of Z in the labor market is just the first round effect, because Z directly appears in the labor demand function, or the intertemporal condition of the firm. A drop in interest rate from R1 to R2 has a second round effect in the labor market, which we have analyzed in slide 11. A drop in interest rate shifts the labor supply curve to the left due to the so-called intertemporal substitution effect via the intertemporal condition. But because this is a second round effect, the magnitude is smaller than the first round effect on the demand side. The eventual effect on the equilibrium labor is from N1 to N2, a bit smaller than that if only first round effect is considered. To summarize, a rise in Z is associated with a rise in output. This is how the classical economists explain business cycles. Since Z is out of the government's control, classical economists usually argued for non-interventionism from the government. 3. The Keynesian and the new Keynesian economists argue that in the short run, it is the demand side that drives business cycles. Let's use the three-step approach again. Step 1. The exogenous variable in question is the government expenditure G on the demand side, and the endogenous variable is again output Y. Step 2. The analysis is about the effect of the government expenditure G on the demand side, which is not an axis variable, so it is about the shifts of curves. Step 3. Start with the rise in G while keeping all the other exogenous variables such as Z unchanged. G is part of the AD curve, so the direct effect occurs on the demand side of the output market, not in the labor input market like the previous analysis. A rise in G pushes both interest rate and output up. This is the first round effect. The second round effect in the labor market is again derived from the intertemporal conditions of the consumer, and it is again due to the intertemporal substitution effect we mentioned many times on the slide 11. A higher interest rate implies a rightward shift of labor supply. This leads to a higher labor, so a rightward shift of the AS curve in the output market. This is the second round effect, so the magnitude is smaller than the first round effect. The eventual effect is that the interest rate rises moderately from R1 to R2, and the output grows significantly from Y1 to Y2. To summarize, a rise in G is associated with a rise in output Y. This is the rationale behind the Keynesian policies. Stimulate the economy when it is in recessions, and cool the economy down when it is in booms. Almost all policymakers are Keynesians. The only difference is how effective the Keynesian policies are. The effectiveness is usually measured by the multiplier effect, defined as the ratio of the change in output over the change in expenditure G. In practice, this multiplier effect can be quite small due to conflicts between the public and private demand. Note that a higher government expenditure G must be financed by the higher tax T, which means a lower after-tax income and a lower private consumption for individual consumers. The public expenditure crowds out the private expenditure. This is called the crowding out effect. This lecture combines everything we have learned up to now to construct an all-in-one RBC model, including the static model and the intratemporal conditions, the dynamic model and the intertemporal conditions, the government's budget constraints and market clearing conditions. The essence of the previous conclusions of simplified RBC models still hold in the all-in-one RBC model. There are two quantitative techniques to analyze the model, namely differentiation for optimization and equation solving for equilibrium. We also introduced the three-step approach to graphically and qualitatively analyze the model, but mathematics cannot be avoided. Finally, we discussed the differences between the classical doctrine and Keynesian doctrine in explaining business cycles and their policy stances. We have now finished the real business cycle models. From next topic onwards, we are going to introduce money into the model and discuss the nominal factors underlying business cycles. Please read the relevant chapter of the textbook and try to do the self-tests.